let's look at the concept of momentum, impulse, and collisions. Momentum, denoted by the letter P, is simply mass in motion. The momentum of an object is the product of the mass times its velocity. So the mass is measured in kgs, velocity is measured in meters per second. Therefore, the units for momentum will be kg meters per second. Now, momentum is a vector quantity, and its direction is dependent on the direction of the velocity. Consider a body of mass 10 kgs moving with a velocity of 3 meters per second. The momentum of this object, or the momentum of this body, will be P is equal to the mass times the velocity, which is mass times the velocity. So it will be 10 times 3, which gives us 30 kg meter per second. If we put another body that is moving in this direction, the momentum of this body is going to be 7 times 2, which is equal to 14 kg meter per second. Now, what if we are asked to find the total momentum of these two bodies that are in an isolated system? The total momentum here will be the momentum of this first body. We can say this is body 1, body number 1. This is body number 2. So this will be momentum 1, momentum 2. So the total momentum here will be momentum 1 plus momentum 2. But we have to consider the direction of this body. The first body here is moving in the positive x axis or positive x direction, meaning its velocity will be positive 3. The other body here is moving in the negative x direction, meaning its velocity will be negative 2. So when doing the calculation, we are going to have total momentum will equal momentum 1 plus momentum 2, which will give us that is our total momentum there. In a case where the bodies are going in the same direction, the total momentum will be the momentum for this object, which will be 3 times 4 plus the momentum for this other object here, which will be 5 times 3, which will give us 12 plus 15, which is equal to 27 kg meter per second. Impulse, denoted by the letter J or imp, is the product of the force and the time interval. And the force is measured in newtons, time is measured in seconds, which makes the units for impulse to be Newton second. A practical example can be an object that is in motion, an object that is already in motion with some velocity. So this object is going in this direction, and then you apply a force in the opposite direction to stop, in order for you to stop the object. For example, you have a moving car that is moving in this direction, and then you apply some brakes to stop it. Now, before the car comes to a stop, it will skid a certain distance. So now, the impulse will be calculated by the force that you applied, which is the brake in this case, or the frictional force on the tires. The force that you applied multiplied by the time interval between the point of application of the force to the time that the car comes to a stop. So the impulse will be calculated by the force, which is the force that has been applied, and the time that it took for the car to come to a stop. Let's now look at the impulse momentum theorem. The impulse momentum theorem states that the impulse applied to an object will equal the change in momentum. Now, let's consider an object, one object that is moving from point A to point B. At point A here, this object will have an initial velocity of u. And then when it reaches point B, it will have a final velocity v. Now, this object will have an initial momentum due to this initial velocity at this point. Then after it has made that movement from point A to point B, it is going to have a final momentum. Now, what is the change in momentum? The change in momentum will be the momentum at the final position minus the momentum at the initial position, which will be mass times the velocity minus the mass times the initial velocity there. So this is what is known as the change in momentum, which is this. Now, consider a body of mass m that is being acted on by a force F. From Newton's second law, we know that this force will produce an acceleration in the direction of the force. From Newton's second law, we know that force is equal to mass times acceleration. But acceleration is equal to velocity, or the change in velocity, divided by the change in time. So n is equal to the change in velocity over the change in time, or maybe the time interval. Meaning, this formula that we have here can be rewritten as force is equal to mass times change in V over change in T. So we've just substituted the acceleration here, which is this term here, with that. And then we also know that the change in velocity is the difference between the final velocity V and the initial velocity U. Meaning, we can substitute this with that. Our equation would be force is equal to mass times the change in velocity over the change in time. At this point, we multiply both sides of the equation by t, or the change in t, or we simply just cross multiply. We're going to have this times that is equal to here. Also, it is possible that we can open the brackets. So let's open the brackets. So this is going to be force times change in time is equal to mass times V will be mv minus mass times u, which is mu. Now when you look at this equation, you will notice that what we have on this side of the equation, we have the impulse, because impulse is given by force times time. The impulse is given by the force times time. So here we have the impulse. Then equals, and what we have here is also the change in momentum, because we have the final momentum minus the initial momentum. Hence, proven. Now, let's look at collisions. And we begin our discussions under collisions with the law of conservation of momentum. This law states that when two bodies collide in an isolated system, the total momentum before collision should equal the total momentum after collision. Now, what does this mean? Here, you have an illustration of two bodies that are about to collide. So this is before they collide, and this is after they collide. It is possible for us to find the total momentum of these two bodies, both in the first stage before they collide and after they collide. So the total momentum for these two bodies before they collide will be the mass of this body times the velocity, which is an initial velocity, plus the mass of this body times the velocity with which it's moving. So it will be mass 1 times initial velocity 1 plus mass 2 times initial velocity 2, which is the total momentum before the bodies collide. So according to the law, it is saying this should equal the total momentum of the two bodies again after they collide. Meaning, here we're going to have the momentum for this plus the momentum for that. So it will be mass 1 times final velocity 1 plus mass 2 times the final velocity 2. Here we need to have a 2, sorry. So this is the law of conservation of momentum. Okay, let's look at the types of collision and how they differ. There are basically two types of collisions. One is an elastic collision, the other one inelastic collision. Elastic and inelastic. The main difference between the two types of collision, elastic and inelastic collision, is in their loss or conservation of kinetic energy, KE. In an inelastic collision, kinetic energy is not conserved. It is transformed into other forms of energy. It can be transformed into heat energy, sound energy, or even radiation energy. Whereas in an elastic collision, kinetic energy is conserved and it does not change form. But what is considered an elastic collision or inelastic collision? So it turns out in an elastic collision, this one, when two bodies collide, after they collide, they split. They do not stick together. Hence the term elastic. So you expect in an elastic collision, when bodies collide, after they collide, they split or they do not stick together. So this body before collision, it will have its own velocity, and this body will have its own velocity. Then after they collide, the velocity will change or might change, but the body will have its own velocity, which is v1 there, and body 2 will also have its own velocity, which is v2. That is under elastic collision. So the principle of conservation of momentum applies even here, and we are going to have the same equation that we looked at, which is mass 1 u1 plus mass 2 times u2 is equal to mass 1 v1 plus mass 2 v2. The principle of conservation of momentum in an elastic collision. Let's look at what happens in an inelastic collision, which is the second one. Now, in this collision, in an inelastic collision, when bodies collide, they stick together after they collide. So what happens here is that since these two bodies become one body, they cannot move with two different velocities after they collide. They are moving with only one velocity there. And even in this type of collision, the principle or the law of conservation of momentum will still apply. And we are going to have this equation, but here we will notice that v1 and v2 will be the same because they will be moving with just one velocity, which is v. So at this point, we're going to say, but v1 is equal to v2, which is just v. So our equation now will change to m1 u1 plus m2 u2 is equal to m1 v plus m2 v. And we can factor out the v here. So this is our law of conservation of momentum under inelastic collision. So for elastic collision, bodies split after collision. Here bodies stick together after collision. Let's look at the coefficient of restitution, denoted by the letter E. So the coefficient of restitution is the ratio of the relative velocity of two objects after collision to the relative velocity of the same object before collision. The coefficient of restitution will be given by E is equal to V2 minus V1 over U1 minus U2. The value for the coefficient of restitution ranges from 0 to 1. So in an elastic collision, the coefficient of restitution is equal to 1. The value for the coefficient of restitution, E, is equal to 1. For meaning this equation that we have here for the coefficient of restitution will be one is equal to V2 minus V1 over U1 minus U2, which can be rewritten as So let's now look at some of the calculations under momentum, impulse, and collisions. Let's now look at some of the calculations under momentum, impulse, and collisions.